Hydroxides.
Notice it, bases are here. If you see that, we have written either they are metal oxides or basically what they are metal hydroxide.
Oxides.
So now we are
Hydroxide.
writing the example. What is the example we are writing? Sodium hydroxide or potassium hydroxide. Please mute yourself, Aswin. What is this? Okay. So metal hydroxides are metal hydroxides are metal oxides. So sodium hydroxide. Sodium is a metal, OH is a hydroxide. So that is what we used to call as base. Okay. So please make it yourself. Now this is what about it. So now let us see. As we know, water soluble bases. What we used to call, guys?
Alkalis.
That is what
Alkalis.
alkalis. Understand? And some bases they do not dissolve in water and they won't form the OH minus ions. Even though they are called as what? Bases only. Understand everybody? Even though they do not dissolve in water and they do not form the OH minus ions, still they are called as what? They are basic in nature. Is it okay, guys? Every soluble base is actually a base. Every alkali is a base, but every base is not a alkali. That is
Alkali.
so that is what is about what is the bases. Now classification of bases only will classify based upon the strength of the bases. So that is what you can say. So classification of the bases on the basis of strength of bases. So only single classification. Okay. So first, on the classification of bases on the basis of strength, you can see. So basis of strength, we can classify first one, strong bases, and as well as opposite one, this one. What is this? Weak bases. Yes or no,
Weak.
guys? That is what. So strong bases, write it. Strong bases, those bases which are fully ionized. Those bases which are fully ionized in all the concentrations, in aqueous medium. Aqueous medium means dissolved in where, guys? All of you? Water.
What?
Yeah, aqueous medium. Mr. Sanjay Kannan, are you there? Nimish, Pugal, Rohit, aqueous medium.
Yes, sir.
And have strong affinity for a proton or strong bases, and have strong affinity. Affinity means attracting. Affinity for a chemical reaction, guys. Strong affinity for a proton or strong bases. Okay. So these substances only, strong bases only we used to call. They are forming. So these are called as what, guys? Alkalis. They're dissolved in water. So they are only called as what? Everybody? We used to call it as alkalis. Understand? So they must, you can see, they must be dissolved all the concentrations in the aqueous medium and they have to form OH minus ions, completely soluble. You can see. So for example, let me take for example, if you take first one, sodium hydroxide. So sodium hydroxide is a strong base. So like powerful like hydrochloric acid. So sodium hydroxide is also very, very powerful. So what is the formula of sodium hydroxide, everybody? NaOH. NaOH is basically, if I take solid, I will make it into dissolved in water. So it will form sodium ions plus OH minus ions. That is what this ions is called as what? Everybody. Hydroxide ions. And this is what ions? All of you? Sodium ions. Understand, Ra? Everybody? Yes, please. Now, you might be noticed. Next, second kind of example. Potassium hydroxide. What is the formula of potassium hydroxide? Everybody? KOH. So this potassium hydroxide is also strong alkali, actually strong base. So if it dissolved in water, it will form potassium ions plus hydroxide ions. So next same way, if we take third example, okay, lithium hydroxide, LiOH. Li is the lithium. Okay, everybody? Lithium hydroxide. If you don't know, you can write it every time. Lithium hydroxide is soluble in water. You can see it will form lithium ions plus OH minus ions. Is it okay, guys? Yes, please.
Yes, sir.
Yeah. Clear? Everybody? Clear?
Yes, sir. Yes, sir.
Right. That is one. Next, weak bases. Opposite to this, weak bases. So you might be all not at all learned till now any kind of weak base example, but we already learned so many things. Do you remember we studied acidity? I already told you if you are having a stomach pain or indigestion, we will take something. Already first chapter I told you that. Anybody?
Yeah.
Yes, anyone? What is the solution? We'll take it. If you consume,
Antacid.
yeah, you consume dyes in this, that, and all. They contains what? It will start with the magnesium hydroxide. Understand? So that is the first actually. Yeah, magnesium hydroxide we used to called as milk of magnesia. Remember this word at least? I have told you or not?
Yes, sir.
Milk of magnesia. So milk of magnesia is actually a magnesium hydroxide. That is only we can say even example of weak base or strong base. Example for weak bases.
Weak base.
So let us see that what is this weak bases, and we'll discuss this. Okay, so weak bases, right? Those bases which do not ionize completely, those bases which do not ionize completely to give OH minus ions. OH minus ions in water and have weak affinity for proton. Proton is called weak bases. Okay, so they will give very, very few OH minus ions in aqueous medium. Okay, make it that also. They give very few OH minus ions in aqueous medium. Sarya, everybody, all of you, that is what. So first example 1, ammonium hydroxide. I want the formula of ammonium hydroxide. Anybody? Yes, please. NH4OH. Write it. Ammonium hydroxide. So, all of you remember, if ammonium hydroxide will react with the water, ammonium hydroxide, all of you write it. Ammonium hydroxide. NH4OH react with water. Basically, it is a double arrow I'm putting. So, means in the sense of what? It is a reversible reaction. Do you all understand, everybody? Reversible reaction. So, it will form NH4 plus OH minus ions. So, this is ammonium ions, not ammonia, ammonium ions. Plus, we are getting what? Everybody?
Hydroxide ions.
Okay. Always remember, if I put single arrow, irreversible reaction. If I put double side arrow, it is indicating what? Everybody?
Irreversible ions.
Reversible reaction. That is what you have to remember. Next, magnesium hydroxide. So that is what we can say. Acidity. You take a dyes in tablets or dyes in pink color syrup and all. So that all contains, you can see what they contains. A weak base called as, what is that called as? Milk of
Magnesium.
magnesium, which is only called as what? Magnesium hydroxide. Understanding? So magnesium hydroxide dissolved in water, that is only we can say milk of magnesia. So understood everybody? So milk of magnesia is actually a mixture of water and magnesium hydroxide. So it is also basically a reversible process. So which will form Mg2 plus 2OH minus. Okay, guys, everybody, 2OH minus. Understand? Please respond. That is what it is. Next, aluminum hydroxide. What is the formula of aluminum hydroxide, Mr. Nimish? Pugal, AlOH thrice. Understanding? Aluminum hydroxide. Sir, how, sir? OH minus. So we all know aluminum 3 and OH is 1. So if we crisscross, we'll get what? Al1 and OH thrice. Okay, guys? So if aluminum react with the water, so we all know, so it will form what? Anybody can tell? Aluminum.
Al3 plus.
Al3 plus 3OH minus. Okay, so that is what you have to remember. Understood, Ra? Please respond. That is what it is. Okay, next, zinc hydroxide. Anybody can tell what is the formula of zinc hydroxide? Mr. Rohit? Mr. Kaushik, no need to ask. He will never open. Okay, zinc hydroxide formula. Any one of you? Mitakshri? ZnOH twice, not ZnOH. ZnOH twice. So how it will comes? Zinc valency is what? 2. Hydroxide valency is 1. So if we crisscross it, so we'll get it what? Zn1OH twice, which is equals to, what is the formula, guys? Everybody? ZnOH. So ZnOH twice, if you have taken, react with the zinc hydroxide. Chemistry, if you don't know the formula, no purpose of study. I am saying you, better you can stop studying if you don't know the formulas. So, okay. So otherwise you learn the formulas. Formulas don't know, no need of studying the chemistry. Entire chemistry is like that only. If you don't know formulas, not necessary to read. So these are the examples of weak bases. So all of you remember. So every strong base is alkalis, but all the weak bases are not called as alkalis. Okay, that is what. Okay. So please make it. Any doubt, ask me. Harizaras, understand?
Sir.
Yeah. Aswin Gokul, Arul.
Yes, sir.
That is what.
Yes, sir.
Any doubt, ask me. Very, very important. Once it is over, then we'll proceed further. Clear, guys? So classification of bases only based on the strength, strong bases and as well as weak bases. So the well-known popular bases for us, aluminum hydroxide also won't come. We will get it, magnesium hydroxide, all of you remember, magnesium hydroxide, sodium hydroxide, and also we'll get one more one. We all people knows, calcium hydroxide, CaOH twice, calcium hydroxide, and as well as you can take main bases, only one base. What is that base? Sodium hydroxide, and very rarely we will use potassium hydroxide also. Lithium hydroxide will never get it. Okay, so that is what you have to remember. Okay, guys, all of you.
Yes, sir.
Now, if you observe very carefully, strong bases and weak bases, one common thing you can find it. So those metals who is having valency of 1, they are forming the strong base, and those metals who is having valency of 2, they are forming the weak bases. Have you checked it, everybody? Verify it, all of you. Magnesium 2, aluminum 3, zinc is also 2. So they are having valency of 2, so that they are forming the weak base. Like all the weak bases, they are having a valency of 2. Have you checked it, everybody? All of you?
Yes, sir.
Yeah.
Yes,
So
sir.
of course, except ammonium hydroxide. Sorry, this is ammonium hydroxide. Ammonium hydroxide is the one and only hydroxide which is actually formed by two polyatomic ions. Ammonium is also polyatomic ion, and hydroxide is also polyatomic ion. On 9th class, you might be all studied one and only positive polyatomic ion. What is that, Ra? Ammonium.
Ammonium.
Ammonium alone is the one and only positive polyatomic ion. Remaining all the polyatomic ions are what? Only positive
Negative.
polyatomic ion. Understanding? So remaining all the polyatomic ions are what? Everybody? Negative only, except ammonium hydroxide. You can, sorry, ammonium. You can check it if you want. So this is what about it, all the bases and what is bases and the classification of bases. And then tomorrow's class, of course, properties we can easily finish. Then tomorrow's class we are going to study properties of bases. So properties of bases means we'll get two properties. One is what properties, everybody? One is physical property and another one is what, everybody?
Chemical
Chemical
properties.
properties. Okay, so let us write physical properties, one or two, and we'll stop it. So first property is, what is the taste of bases, everybody? All of you?
Bitter in
Bitter in taste. That is what. Okay, bases are bitter in taste. Bases are bitter in taste. What is the example? Bitter in taste. I have taught you already just now today. Yes.
soap.
Yeah, like a soap, or if you have a Dyson, that is what we can say. What is that? Milk of magnesia.
Magnesia.
Okay, so that is
Yes.
what you have to remember. And also remember, bases are like soap, slippery in nature. Okay, slippery in nature. That is what you can say that. That is only we can say soapy to touch. So if you touch them, soapy in touch, we used to call it as. Means they give slippery feel when we touch that. They give slippery feel when touched. That is what you have to remember. Is it okay, guys? All of you? Yes, please. And same way, like acids, bases also, strong bases, they are also corrosive in nature. Okay. Bases also, acids also corrosive in nature, and bases also corrosive in nature. Is it okay, guys? But bases can corrode. Acids can corrode what, guys? Anybody can tell? Acids can corrode what? Metals or not? Yes or no? All of you, metal surfaces. So these bases, they can corrode various things, like they can corrode the wood, they can corrode the paper, and they can corrode our skin also. So that is what you have to remember it. Of course, strong base can burn our skin, same like acid. So that is what it is. Next, few bases are soluble in water. So soluble bases, what we used to call, everybody? Soluble in
Alkali.
water. Alkalis. Okay, so they are soluble in water. But who will soluble more? Strong bases or weak bases? Everybody?
Strong base.
Strong bases. So they are soluble in water. But weak bases are lies, feebly soluble, means very little amount. But weak bases are feebly, F-E-E-B-L-Y, feebly soluble. Okay, so that is what. Like, what is the example? Milk of magnesia. Magnesium hydroxide is not fully soluble. Okay, understand everybody? Because it's a strong base or weak base. Everybody?
Weak base.
Weak base. That is what you can remember. Okay, so feebly means in the way that lacks strength or force. Lacks strength. That is why it is called as weak base or strong base. Example, magnesium hydroxide, weak base. Understand? Everybody? Clear, everyone? Next. So now they are also forming the ions. They can conduct the electricity or not, guys? Everybody? Yes, please. Like acids? Yes, please. All of you. So they are also conductor of what? They are also conductor of electricity, because they are also forming the ions when they dissolve in water. So when these bases are aqueous solution, when the bases are aqueous medium, so what will happen, guys? They can conduct what? Everybody?
Electricity.
They can conduct electricity, because they also will form the ions. Conduct electricity. as they get dissociated or ionized. Ionized into what? Everybody? Ionized
Water.
into what? Ionized into
Hydroxyl.
understanding. So any substance, if it will forms ions, then it will turns into a good conductor of electricity or bad conductor of electricity. Everybody, it will turns into a good conductor of electricity. Same way. That is what. Then last property. Acids are having high melting points and boiling points. Then what about bases? Bases also having what? Everybody? High melting and yes, please. Boiling points. Okay. Write it. So bases also having high melting and boiling points. Is it okay, guys? All of you? Yes, please. That is what. So they have high melting and boiling. Boiling means BP, we can say, everybody. Melting means MP, melting points. So these are the 6 physical properties of bases. Then tomorrow's class we'll see what is the chemical properties of bases and what is the uses of common bases. And last one is, after once it is completed, we are going to study what the common characteristics of acids and bases means, what acid contains and as well as what base contains and what is their common characteristics. That is what we people will discuss. And later we'll discuss how to decide the strength of the acid and how to decide the strength of the base and what is importance of the like how to identify the strength of the acid base and all. We'll discuss it. Okay, guys. So let it be with this. I'll stop and you can relax for 1 hour and get back to the work by 7 o'clock. And you continue as usual. Afternoon we'll meet by sharply 2:30. Thank you, everybody.
Thank
Thank you.